Hello and welcome back, ladies and gentlemen, for the final part of your virtual lab where we are testing these 6 foods for macromolecules. Today we're going to be looking for lipids or fats. So just a reminder of the 6 foods that we are looking at. We have mashed potatoes, peanut butter, peanut oil, corn syrup, cornstarch, and table sugar. We are not testing our 2 solvents today. In fact, we are using one of these solvents, the water, to run the solubility test. And you'll see that I've colored it green to help us see it better. So what it means to be soluble is that one material will dissolve in another. So we are going to be using water to see if these different foods will dissolve in that water. If they do not, if the food is insoluble, then it will form layers with that water, and that will indicate that we have lipids present. So I'm going to set up much in the same way that I did for carbohydrates and proteins by taking 2 pipettes or droppers worth of each solution and putting it into these test tubes, being very careful not to contaminate. Now I really just want to get the liquid part that has the food dissolved into it. As I am filling these different test tubes, I do want you to make your hypothesis. Keep in mind that a hypothesis is an if-then statement. If I test this, then this is what I expect to see. So which of these foods do you think have lipids in them? Hopefully you have made your hypothesis. I have set up by putting 2 pipettes worth of each food in each test tube, being very careful not to contaminate. So now what I'm going to do is run the test. And to do that, I'm just going to take 1 pipette's worth of this water that I have colored green and put it into each test tube, looking for layers. If I have layers, then I know that I have lipids. Okay, so I now have run the test. I have dropped 1 pipette's worth of my green water into each one of these test tubes. And remember, I'm looking for layering, and if I have layers, then I know that I have lipids. So let me bring this closer. If we look closer, we can see that most of these foods have dissolved in water pretty well, but we do have a couple of examples in solutions 2 and 3 where we do have layering, and you can see that here and here. That indicates that we have lipids present in solutions 2 and 3. And notice that the food is on the top. That would be where the lipid is. The water is on the bottom because lipids typically are going to be lighter than water. So we can go ahead and check off solutions 2 and 3 as having lipids. That would be our peanut butter and our peanut oil. So let's investigate the nutrition facts to see if they match our results. So remember, we just tested for lipids, and lipids are fats. So if I want to investigate my nutrition facts, then I'm going to be looking for total fat. If I look at mashed potatoes, I have 0 grams of fat. If I look at my peanut butter, I have about 15 grams of fat per serving. With my peanut oil, I have 14 grams of fat per serving. With corn syrup, I have 0 grams of fat per serving. Cornstarch, 0 grams of fat. And our table sugar, we have 0 grams of fat. So all the nutrition facts match our results pretty well. When we think about why the solubility test works, it comes down to the structure of water itself. Water molecules are polar, which means they have charges on each end, and those charges interact with each other to pull those water molecules really tightly together. It's why you see water bead up on your car windows and things when it rains. So if we're thinking about polar substances, they will dissolve other polar substances. And nonpolar substances that don't have charges at each end of their molecules will dissolve other nonpolar substances, like fats. That's why I had to use alcohol, a nonpolar substance, to dissolve my peanut butter. So think about washing your dishes. You can't use just water alone to get the grease off of your pans. You have to add soap to that water. Soap is what we call a surfactant, and it's going to get in between those water molecules and disrupt their charges, so that when we can separate those water molecules a little bit with the soap, you can then dissolve something like a lipid into it and clean your dishes better. We are also going to test these foods using what's called the spot test, and so I'm going to bring this a little closer. We're also going to be using what is called the spot test in order to test for lipids, and I bet you've done something like this before. If you've ever gone and gotten fatty fast food and left it in the bag overnight and you see that bag the next day, it's got all this greasy spots on it. And that's essentially what we're doing with the spot test, only we're using brown paper. So you can see that I've gone through and I have drawn circles and put numbers above each circle. The circle is to indicate where I put the spot, and the number is to indicate which food went into the spot. So what I'm going to be looking for is a greasy spot to be left in this circle after this dries. So I'm not actually going to let this dry and show you on this video, but I will post this picture to Canvas so that you can see which of our foods do have lipids in them. But I will show you how to run the spot test. In order to run the spot test, it's very simple. I'm just going to take 1 drop of each food and put it in the circle that I just showed you, and then we'll look for a greasy spot once this has had time to dry. I've put 1 drop of each food in each circle, being careful not to contaminate, and I'm going to let this dry, and like I said, I will post this picture to Canvas for you to see the results of your spot test. I hope you enjoyed this lab, and I hope it was informative for you.